Alright, today we're going to talk about factoring polynomials. There are four things we're going to go through. We're going to talk about factoring by factoring out a monomial, factoring by grouping, factoring by recognizing a special pattern, not pattern, special pattern, and factor by a polynomial in quadratic form. Okay, so this will all make more sense once we actually go through them, but this is what we're going to get through in this video. Alright, first of all, the first thing this depends on is being able to factor quadratic. So we'll do some review in class. We'll definitely give you guys some work to do. But if you're really concerned about it, or if you feel like you never really quite got that, please check out Khan Academy. And I'm just going to preview that for you real quick. This is the link, but here's what it looks like. It's going to send you to a page like this where you have some videos you can watch. You're welcome to watch the videos, but what I would really recommend you doing is going down on the left-hand side here and doing these practice problems. The practice problem parts are denoted with the stars. The videos are denoted with arrows. So if there's something you want to review on, these are nice videos to watch. But I like these. I can practice factoring a polynomial here, and it'll tell me if I got the answer right or wrong and give me hints as to how well I did. If I get 5 correct in a row, I go on to the next type of problem, right? So there's factoring quadratics 1, factoring quadratics 2, and you can go on and practice and practice and practice, okay? So this is a really great place to start if you're really uncomfortable with your factoring skills, if you want to catch up on something that maybe you feel like you didn't quite learn as well the first time. And notice they give you an opportunity to show me how. They give you some videos to watch that pertain to what you're doing currently. Okay, so this is a really nice way to review topics if you feel uncomfortable about them. Okay, so factoring quadratics. The next thing we want to look at, obviously, is what is a factored polynomial. So a factored polynomial is one that has been reduced to a product of unfactorable polynomials. It almost sounds circular, frankly. This one is factored already. It's already in its most factored form. Let's take a look at it. X minus 2. I can't write that as a product of any other polynomials. X squared plus 1. Okay, I can't factor that over the real numbers. Okay, it has complex factoring, but I can't factor it over the real numbers at all. I cannot write x squared plus 1 as the product of 2 other polynomials. This one is factorable. This one is not factored yet. Okay, because this one can be written as x plus 3, x minus 3, x minus 1. Now this is a factored form, completely factored form of my original f. Okay. A quick note is that anytime you have x plus or minus a number, that is as factored as it can be. The linear form, the lines are the most factored that you can possibly get. Okay. So I want to introduce some terminology here that perhaps I was remiss in not mentioning previously, and that is types of polynomials. Now, we've talked about types based on their degree. These are types of polynomials where we base them on how many terms they have. Okay, a term in a polynomial is what we have in between the pluses or the minuses. So, for instance, a monomial, mono, right, is one term. There is no plus or minus in a monomial. It's just one thing. Okay? A binomial has one plus or minus in it, right? X minus 1. X squared plus x. 3x squared minus 3. Okay, so a binomial has 2. A trinomial has 3 terms. X squared minus 3x plus 1 is 3 things, so two pluses or minuses. X to the 10th minus 1/2 x to the 4th plus 4. We could obviously talk about 4-term polynomials, but after that they start losing names. Okay, so we would just say this polynomial has 4 terms. You wouldn't go any further than that. You would just simply say that's it. Okay, or 4 summands. Okay, so let's talk about some methods for factoring. The first method is to start by factoring out a monomial. We look at this function f of x and we say, is there anything I can factor out of all 3 terms? Is there anything in common? I've got x cubed 2x squared minus 15x. There's an x in every single term, so I can write the x out here. Aha, that's pretty good. I can't seem to put a parenthesis. There it is. Okay. That's pretty gosh darn good. The x is factorable. And now we ask the question, can we factor the rest? This is a quadratic, and this is why the quadratic review is important. Can we factor x squared plus 2x minus 15? Okay, well 15 is 3 times 5. Okay, so if I put a 3 and a 5 here, can I find a combination of 3 and 5, one that has to be negative, so that I get positive 2 in the middle? That will work. If I FOIL this out and multiply an x back through, I'll get my original. And this is as factored as we can get. The second method is called factor by grouping. And many of you have done this before. Factor by grouping is a little tricky. Okay, what we have to do is we have to pair these up. Okay, usually it's 4 terms, and we have to pair it up in a way so that we see things in commons between the pairs. So let's just start with the pairs we have so far. X cubed minus 3x squared. Okay, and we'll do minus 16x minus 48. Okay, now, first things first, notice that I wrote the negative here because if I put a negative 16, this distributes both through to the 16 and to the 48, which would make this, if I distribute the negative 16 and positive 48. It's going to make our life a little bit easier in a few minutes here, but I just want to point out that I factored out a negative 1. Okay, now look at this and I say, is there anything I can factor out of this equation here? Is there any monomial I can factor out? And there is. X squared is common to both. We're left with an x and a 3. Is there anything I can factor out of 16 and 48? Oh, well, wait. 16 times 3 is 48. I can factor out a 3. Oh, pardon me, I can factor out a 16. I could factor out a 3. Well, that's not going to work. I can factor out a 16 and be left with a 3. Okay? So when we factor by grouping, it's always a bit of a crapshoot, really. Okay? We try to pair up the two so that I can factor something out of the first pair and factor something out of the second pair. If everything goes well, and this was the best method to use, now we should have some number times a factor and some number times another factor, and if everything went well, these factors will be the same. Okay? Notice I have an x minus 3 and an x minus 3. That's a good thing, because now what I have is x squared times x minus 3 and 16 times x minus 3. I can factor out an x minus 3 out of this and an x minus 3 out of this. So now I have x minus 3. What's left? From this term I have an x squared left, and from this term I have a negative 16 left. Can this be factored anymore? So this was the factor by grouping step here. We factored by grouping. That's the step where we did it. Now we go back again to think about quadratics. Can we factor this quadratic? This is a difference of 2 squares. And yes, it factors as x minus 4 times x plus 4. Okay? So that's the concept. Oftentimes with all these factoring methods for higher order polynomials, 3 and up is a higher order polynomial for us. Oftentimes it's going to be reducing the problem to something times a quadratic. So you've got to be able to factor a quadratic for this to work. So that's method 2, factor by grouping. Method 3 is a little bit artificial maybe, and it's recognizing a special pattern. Now these are the 2 special patterns we're going to add into this section. We've talked about recognizing difference of squares. This is x squared, and this is 2 squared. Now I'm going to say we can recognize difference or sums of cubes. We can factor sums of cubes as well as difference of cubes. Okay, So if I can recognize, and here's the formula for sum of cubes, and here's the formula for difference of cubes. Notice the only difference between the two formulas is that. Okay? Only difference is that. Oh, no. And this should be a negative. Big minus there. Okay. So a minus b. A squared plus ab plus b squared. So this sign here is always the same as the sign up front. And this is the opposite. If it was plus here, it's minus here. If it was minus here, it's plus here. Okay? All right. So let's look at this. Can we factor this using one of these two formulas? Well, I put this on here, so hopefully we can. This is x cubed. Is this anything cubed? Well, yeah, it is. It's 4 cubed. 4 times 4 is 16 times 4 is 64. I can write this as x cubed plus 4 cubed, and now I can use my sum of cubes formula. A cubed plus b cubed is a plus b, so in my case it's x plus 4, and then we'll have x squared minus 4x plus 16. Now I'll give you a hint. These are never factorable. Okay, so it's just that's kind of a nice hint. Whenever we finish the sum of cubes or the difference of cubes, this is the completely factored form right here, the entire thing. We never have to do the next step. Okay, the final form is factoring in quadratic form. The final version, pardon me, is factoring in quadratic form. Now, this does not look like a quadratic. It's a degree 8, okay? But we can turn it into a degree 2. And I'll show you what I mean. So first, let's start off with what we know before. We tried by factoring out a monomial, because that's a good method if we can do it. Well, we have all these are even numbers, so they'll have 2's in them. And they've all got at least 2 x's. So if I factor out 2x, what am I left with? I'm left with, okay, x to the, 2x squared. I can factor that. X to the 6th plus 10 divided by 2 is 5. I factored out 2 copies of x, so this is almost with 3 of those. And down here I'm left with 6. Now again, this does not look like a quadratic. But it should look kind of weird, right? Kind of interesting, like something maybe you've seen before. Well, here's what's kind of interesting about this. X to the 6th is x cubed squared. Can you see that? X to the 6th is x to the 3rd all squared. Okay? So in a certain sense, this is like a quadratic. It's a quadratic form. It's not a quadratic expression, but it's a quadratic form. If we think of this as not as x squared by itself, but as x cubed squared, then we can kind of pretend this is a quadratic. Here's what I mean. Okay, I'm going to try to factor this not as x and x, but as x cubed and x cubed. Okay, because when I multiply x cubed by x cubed, I'm going to get x to the 6th. Let's see how this works here. If I try to factor this as if this were kind of an x squared and this were an x. Okay, well, what are some factors that are going to multiply to 6 and add to 5? Well, how about 2 and 3? Will that work? Yeah. Okay. So, we're set. Okay, we've got 2x cubed, and we've got x cubed plus 3, and x cubed plus 2. And that, my friends, is all she wrote. Okay, so we've got our four methods here. In fact, first of all, we always look to try to factor out a monomial. This is the easiest, so if we can do this, we start here. Next thing, we think about factor by grouping. We'll do some practice with this one. Recognizing one of these new special patterns. and factoring something that is not a quadratic, but we can kind of make look like a quadratic. All right, guys, thanks.